Hello students, now we will discuss about finding the maximum height of a projectile motion of an object in projectile motion in 4 different methods. So you would have learned different concepts in physics, right? Let's try to apply all the concepts to a single problem and see how to approach the same problem in different perspectives. So the 4 different perspectives that I am going to show in this video are, we are going to derive the expression for maximum height of an object which is in the projectile motion using the method of kinematics. Then I will use the concept of energy conservation. Then I will use work energy theorem. And lastly, I will be using the method of calculus, that is mathematics, to find. So let's start with the concept. So we know that when an object is projected at an angle theta with respect to the horizontal, it travels in a parabolic path. Right? It travels in a parabolic path. And we know the expression for maximum height is u square sine square theta divided by 2g. So this one you would have learnt using the method of kinematics. So whenever you have the kinematic method, how do we approach it? See, wherever you see the concept of maximum height. So whenever you have maximum height, the 3 equations of motion are v is equal to u plus at, s is equal to ut plus half at square, and v square minus u square is equal to 2as. So wherever you see maximum height, you need to apply the formula of v square minus u square is equal to 2as. So v square minus u square, if I apply 2as along the y direction, then vy square is minus uy square is equal to 2 into ay into sy. So what is going to be the vertical velocity of the object at the maximum height? It is going to be 0, right? Minus this initial velocity can be resolved into 2 components. One is u cos theta and the second is u sin theta. So what is the initial velocity that is acting along the vertical direction? That is u sin theta, right? So it will be u square sin square theta is equal to 2 into, we know that the acceleration of the object is in the downward direction. So it is going to be minus g, and the displacement of the object from point O to A is in the upward direction, right? So this I will take it as h max. So minus and minus gets cancelled. So we know that h max is equal to u square sin square theta divided by 2g. So this is a known fact, right? Now let's try to approach the same concept using the method of energy conservation. So we know from the statement of energy conservation that wherever the forces acting in the system are conservative in nature, right? Wherever the forces acting in the system are conservative in nature, we can say that the energy of the system at every point is conserved. Means the total mechanical energy of the system is going to be a constant, right? Now I will take 2 different points in the journey. Now the first question we need to answer is this object traveling under the influence of a conservative force? Yes, the answer is yes, because it is traveling under the influence of gravitational force. We know that gravitational force is conservative in nature, right? If that is the case, then applying the energy conservation. So this is method 2, observe. So when I apply energy conservation, I will say that the total energy of the object at point O will be equal to the total energy of the object at point A. Let's say the mass of the object which is being projected is m. Now what is the total energy it possesses at point at point O? It is going to be kinetic energy. Now this kinetic energy is getting converted to what form of energy at point A? One is gravitational potential energy and the second is the kinetic energy due to the horizontal velocity, horizontal component of the velocity existing at the topmost point. So what is going to be the total energy at point O? It is going to be half m into the velocity square, half mu square. This is getting converted to, what is the total energy at point A? It is the gravitational potential energy plus the kinetic energy. So what is the gravitational potential energy at point A? It is going to be mgh plus half into, what is the horizontal component of velocity existing at this point? It is going to be u cos theta. We know that the object doesn't experience the force in horizontal direction, hence the velocity is going to be constant. Which velocity? The horizontal velocity. So half into m into, the velocity is going to be u cos theta the whole square, right? Now if I try to solve this, m will get cancelled, So u square by 2 is equal to gh plus u square cos square theta divided by 2. So which implies gh will be equal to u square by 2 into 1 minus cos square theta, right? So which implies h will be equal to u square. We know that 1 minus cos square theta is sin square theta. So u square sin square theta divided by 2 into, when the g goes to the other side, it will be u square sin square theta divided by 2g. So this is one of the ways in which we can derive the same expression. Now let's look at the third method. So the third method is work energy theorem. Work energy theorem. So what does work energy theorem state? It states that the sum of the work done by all the forces, the sum of work done by all the forces in the system is equal to the change in kinetic energy. So work done by all the external forces on the system will be equal to the change in kinetic energy. Now let's try to analyze the situation. So when the object is going from O to A, what is the only force that is acting on the object? It is nothing but its own weight. Its own weight is acting in the downward direction and the object is traveling in the upward direction. We know that work done by any force is F into S into cos theta, right? You don't get confused with this theta. So F into S into cos theta, where theta is the angle between the force and the displacement. Remember, the force is in the downward direction and the displacement is in the upward direction. I will call it as H max. So to avoid confusion, I am changing the value to alpha here. Okay, F into S into cos alpha is equal to the change in kinetic energy. That is final kinetic energy minus the initial kinetic energy. Now observe, I am applying the concept of work energy theorem between the points O and A. Okay. So what is the work done by the force between the points O and A? The force is mg into what is the displacement it has caused? It is H max, right? So it is H max into what is the angle between both? Since they are anti-parallel vectors, the angle is going to be 180 degrees is equal to what is going to be the final energy? Final kinetic energy at this point will be half into m into u cos theta square, right? So it is half into m into u square cos square theta minus what is the initial kinetic energy? It is half m u square, right? So what is cos 180? Cos 180 is minus 1. So you can write it as minus mg into h max is equal to half into mu square into cos square theta minus 1. So can you write it like this? So minus mg into h max will be equal to half mu square into cos square theta will be minus sin square theta. So this minus and minus are gone, m and m is common. So you will get h max is equal to u square sin square theta divided by 2 is already there. This g goes to the other side. It will be u square sin square theta by 2g. Again, we are obtaining the same result. And the last method of all is we are going to use pure mathematics to solve a physics problem. Okay, this is very important. Observe. So method 4 is going to be calculus method. So for using calculus method, I use the concept of differentiation. So you would have learned this concept whenever there is a curve, right? At the highest point, if you draw a tangent, the tangent will be parallel to the x-axis. So according to the differentiation concept, we know dy by dx gives us the slope of the tangent at a particular point. So dy by dx is going to be equal to 0, right? We know the equation of projectile. Equation of projectile is y is equal to x tan theta minus gx square divided by 2u square cos square theta. Now what I am going to do is I will differentiate y with respect to x. So dy by dx should be equal to 0. So dy by dx is nothing but x into tan theta. So with respect to x, theta is a constant. So it will be tan theta into derivative of x with respect to x minus, again x is the variable, this whole thing is going to be a constant. So g divided by 2u square cos square theta into d by dx of x square, right? So this one will be equal to, so derivative of x with respect to x is 1, so it will be tan theta minus g divided by 2u square cos square theta into 2x. If I equate it to 0, then I will get 2x, so 2 and 2 will get cancelled here, right? Now what I can do is gx divided by u square cos square theta is equal to tan theta, so which implies x will be equal to u square cos square theta into tan theta divided by g. So remember, tan can be written as sin by cos. So one cos will get cancelled, you will get it as u square sin theta cos theta whole divided by g. So this is the value of x. So from this, what is it we are able to understand? So the coordinate of this point x is going to be u square sine theta cos theta divided by g. Now if I take this value and substitute it in the place of the equation, then you will get y is equal to, we know the equation, x tan theta. So in the place of x I am substituting u square sine theta cos theta divided by g into, instead of tan theta I am writing it as sine theta divided by cos theta minus g divided by 2u square cos square theta into, in the place of x I am writing it as u, so x square, it is u power 4 sine square theta cos square theta whole divided by g square, right? So this cos square theta and cos square theta is gone, u square and u power 4 it goes 2 times and g gets cancelled. So this, in this place we cancel cos theta and cos theta. So you are left out with u square sine square theta by g minus u square sine square theta by 2g. So when you subtract both, you will get u square sine square theta by 2g. So this is the value of y, but what is this y? This y is the value of h max. So from this we can understand that the same problem and the same concept can be approached from different perspectives.